So good morning all. So today we are going to continue our class with yesterday's topic. Okay, so yesterday we are discussing on essential data required for designing of the bridges, isn't it? Right. So actually we have listed what are the main essential data required. So in that each data, each design data having a few important heads. Okay, so that we are going to discuss it today. Okay, right. So let me share the screen. Okay, right. Essential data, design data for bridges. Okay, right. So yesterday we have discussed on general data, isn't it? What are the general data? What type of data you required, to design the bridges? So first one is name of the road and its classification, and next one is name of the stream, right? Isn't it? General data, right? So name of the stream, and next one. What is the next one? Location of the nearest benchmark and reduced level, isn't it? And next, existing arrangements for crossing the stream, okay, during the dry seasons and during the monsoon seasons, right? And the final one is history of earthquake disturbances. Okay, is there any earthquake disturbances? So that you are supposed to know. Understand? So these are the general data required to design the bridge. Okay, and the next one, which is about catchment area and runoff data. Catchment area and runoff data. So now tell me what you required. What are the catchment area and runoff data required? Guys, is my screen visible to everyone?
Yes, sir. Visible, sir.
Right. Okay. So tell me now, what is the catchment area and runoff data? Em kavali? First one, we should know about the catchment area. What do you mean catchment area? So when you're constructing a bridge over a river, so definitely one should know what is the catchment area of that particular water. Okay. So here you should know whether the catchment area is hilly terrain or plain ga unda anedi chudali. Okay, understand? So whether the catchment area is hilly terrain or any kind of plain area na anedi first we should know. Okay, and next one, next important data which we require is maximum recorded rainfall. Okay, in that particular area, what is the maximum recorded rainfall intensity and what is the frequency of the rainfall in the catchment area? Okay, two things. One is intensity. Okay, and the next one is frequency. How frequent the rainfall will occur in that particular location. Okay, that is very, very important to have a design of bridges. Okay, and the next one, rainfall in centimeters. Okay, rainfall in centimeters per year. Understand? So what is the average annual rainfall in that particular area in terms of centimeters per year? Okay, so in that way we should even get the data in terms of catchment area and runoff data. Okay, and next one, what is the length and width of the catchment area in terms of kilometer? Length and width of catchment area. Okay, in kilometers. We want everything in kilometers. What do you mean that? For example, the river is flowing stream like this. Okay, stream is the okay, so this is the stream. Okay, I should know what is the maximum width of this stream and what is the total length of this stream. Understand? In terms of kilometers. Okay, this information also I need in terms of designing the bridges. Okay, length and width of catchment area in terms of kilometers, right? And the last one in catchment area, what is the nature of catchment and its shape? Nature of catchment and its shape. Okay, what do you mean that? What is the nature of the catchment? Okay, how the water is flowing into this river. Okay, what is the nature? Okay, how frequently the water will come into this river? Okay, so what is the time period of this catchment area? Okay, in the whole year, 12 months, whether the water will be there or not. Okay, what is the dry season? What is the monsoon season? Okay, so what is the maximum capacity of this catchment area? Right? What is the nature and what is the shape? Whether it is straight or curved or inclined or what? Okay, that is how even we should know what is the nature of catchment and its particular shape. Understand? So this is also one of the important in terms of catchment area and runoff data. Clear? Guys, is second part clear on that? Then we can go to the next one. Another the catchment area and runoff data. Guys, please respond. Hello.
Sir, yes, sir.
Yes, right. So please respond immediately so we can go through. Okay, right. So now let's discuss the third one. What is the third one? Data regarding nature of stream. Okay, what is the nature of that particular stream? This is also very, very important because designing the bridges over a river or over a water obstacle is very, very important, and that is very cumbersome compared with any bridge designing over a road or a railways. Understand? That's why you require more data, okay, related to that water or related to that stream when you are designing the bridge over a river obstacle. Okay, that's why you need a lot of information on this. Okay, right. So what is the data required based on the nature of the stream? First one, the stream can be a stream, whatever the stream untundi kada, a stream, it can be an alluvial soil, so nothing but with the erodible bank. Erodible banks. Understand? What do you mean that? For example, there is a this is how the stream water stream is. Okay, right? So what are the banks? So this is nothing but the bank, right? Clear? For any river, so there will be a bank on either side, right? So this is the bank, river bank. Okay, okay, right. And the water which is flowing in this direction. Okay, let us consider like this. Okay, right. Now, first one, data regarding nature of the stream. First, let's see whether the bank alluvial with erodible banks or not anedi we have to see. Okay, erodible banks lekapothe quasi under quasi alluvial. Okay, and next one is rigid bank. Rigid bank or rigid bed. Understand? So let's first we have to know whether the bank or nothing but the soil which is at the edges of the river, whether the soil is erodible soil, like the quasi soil, like the rigid soil, ante etuvanti erosion ledu. Alanti soil ane first we have to know. Okay. Can anyone tell me what is the problem if the soil is having more erodible? Ekku erode ayyindanukondi, what happens? Soil erosion undanukondi ekkuga, what will happen? Can anyone? If I construct a bridge here, so this is our bridge. Okay, if the soil is getting eroded continuously, what happens?
Silt deposit.
Very good. So the whole silt will get deposited. The soil erosion that all will get deposit at the obstruction. Ikkada ee river obstruction enti mana bridge. So our bridge is an obstruction, so that the whole erodible soil will get deposited at this particular bridge. Okay, so that also will affect our bridge anamata. Okay, so that's why we have to know whether the soil is erodible soil or not. That based on that only you are going to design your piers, I mean vertical pillars, in a circular shape, lekapothe rectangular shape, okay, or else like this E shape anedi they will decide. Understand? Okay, this always will affect the water flow. Okay, if the water is flowing piers, so water can flow like this easily. I think make a rectangular or square piers and what happens if the water is flowing like this, these edges will get eroded. Okay, understand? So that's why water flow, based on the water flow, based on the velocity of water, the pier shape, pier dimension will be designed. Understand? Pier and a vertical member, okay, vertical column, right? So that is what, which is very, very important, right? And the next one, the stream can be perennial streamer, seasonal streamer, or tidal streamer. Okay, that we have to know. Okay, what do you mean perennial, what do you mean seasonal, and what do you mean tidal? What do you mean perennial?
Hold the year.
Whole the year. Okay, complete year water ippudu flow avutune untundi. Seasonal ante, as I said, monsoon seasons lone water untundi. Dry seasons lo, I mean summer seasons lo, there won't be any water. And next one, tidal, ante the water which is flowing with more velocity, with more tides, with more heights. Okay, the water will have that wave action. Okay, so what type of water it is anedi kuda manam decide cheyali. Okay, that reflects the nature of the stream. Perennial streamer, seasonal streamer, and tidal streamer. Okay, that information also we should know while designing the bridge. Okay, next one, the extent of meandering of, if any experienced in the past, I mean any bad experience in the past, that also we should know. Bad experience in the sense, having huge monsoons affects nearby structures. Okay, already old bridges untai, there will be small bridges to cross this obstacle. Whether that bridges have damaged due to this heavy tides kavachu, lakapothe due to heavy monsoons kavachu, that bad experiences information also we have to know, okay, before designing the new bridges. Understand? Right, next one, banks at the proposed site can be banks. I'm talking about these banks. Okay, banks anevi what, so we have to see whether the banks are firm and steep ga unnaya leda. Okay, and firm but gently sloping unnaya, or erodable and indefinite unnaya leva check chesukovali. Understand? So these banks, so whether the banks are sloped banks, lakapothe rigid banks, okay, or erodable banks anedi kuda compulsory we have to go through. Right? Clear? Right. So the next one, I mean in the same we have 13 points anamata. Okay, let me discuss one by one, because you have to write all these points. Okay, whenever you come across question like what are the essential design data for the bridges. Okay, right. Next point, same in the third one on the fifth point. What is nature of the stream in the vicinity of the proposed site? What is the nature of the stream? What is that particular nature of the stream? Whether it is a clean bed under the water which is flowing in the river. Okay, below that, whether the bed is clean bed at banks, okay, with or without stones, with or without stones or weeds unda leda. Okay, and next one, any section with weedy or with deep pools unnaya leva anedi check chesukovali. Understand? Clear? So nothing but the same. So water stream undi. Okay, in this water stream, whether this bed, idi bed under. Okay, in this bed, whether the bed is with or without stones, దీనిలో లోపల stones ఉన్నాయా లేవా, ఓకే, లేకపోతే వీడ్స్ ఉన్నాయా లేదా, ఒక డీప్ పూల్స్. ఓకే, సో at some places in the rivers there will be huge deep pools ఉంటాయి. ఓకే, అలా ఉందా లేదా అనేది కూడా మనం చెక్ చేసుకోవాలి ఫర్ ద డిజైనింగ్ ఆఫ్ ద బ్రిడ్జెస్. ఓకే, అండ్ ద నెక్స్ట్ వన్, what is LWL details? Understand what is the low water level details at that particular river, at that particular location మనం తెలుసుకోవాలి, right? So what is the LWL details? Okay, next one, what is the ordinary flood level? Very important, which is called OFL అంటారు. ఈ డీటెయిల్స్ కూడా we have to collect. Understand? See, one should know the difference of all these. What is LWL? What is OFL? What is HFL? Low water level, ordinary flood level, high flood level. These three will always be indicated on bridge drawings. Okay, okay, low water level, ordinary flood level, and high flood levels. Okay, these are very, very important. Okay, that information also we have to get before designing the bridges. Okay, next one is HFL details. And high flood level details kuda collect cheyali. Okay, from where you are going to get these details, Amma? Can anyone? Because after collecting these details, if you come across any bridges in the real applications, you may find the level of flood level marks on the pier, on the bridge pier మీద yellow mark చేసి ఉంటారు. This is the high flood level, this is the low water level, this is the ordinary flood level అని yellow mark తో మార్క్ చేసి ఉంటారు ప్రతి bridges మీద, if the bridges are constructed on the river. Okay, so that is very important. So can anyone tell me from where you are going to get these details? Low water level, high flood level, ordinary flood level, ekkadi nunchi vastayi? From where? Who will give these details? Cheppali, who will give these details? Which department will give these details? At least tell me. Which department? So irrigation department. Okay, so I mean, so where they are related to dams, reservoirs. Okay, so ee details unna evaithe departments unnayo aa departments vallu they will give, because for every river usually there will be a dams which were constructed, okay, which cross the river. Okay, so because from the rivers only your reservoirs catchment area will be located. Understand? So from there you can able to get the information of low water levels, ordinary flood level, and high flood levels of that particular stream. Okay, understand, of that particular stream, right? Okay, and the next one, RL of score depth. What do you mean RL? Reduced level. Okay, reduced levels also we need to know the score depth of the particular location. Okay, and the next one, location on plan about trial pits boring. So one should identify what is the location on plan. Okay, for what? For trial pits boring, because you have already seen number of places, if they want to construct any bridge, first they will go for trial pit borings to know what is the soil strata, soil structure below the ground. Okay, till what depth you can go for the foundation. Okay, that gives that pit borings will give information about what type of foundation you have to decide, and what is the maximum depth where you can get the hard strata. That all information you are going to get only from the trial pit borings anamata. Okay, so that also you have to locate where you can able to get the trial pit borings and all. Okay, that information also you need to design the bridges. Okay, and next one, allocable BC of the strata at foundation level. Okay, what is the strata? Strata at foundation level. Foundation level దగ్గర what is the strata? BC strata కావాలి. ఏంటి, what do you mean BC అమ్మా? What do you mean BC? So what he is telling, I need BC of the strata at foundation level. Foundation level దగ్గర నాకు BC data కావాలి. What do you mean BC? ఏంటి BC అంటే bearing capacity of that particular soil. Okay, so we need what is the bearing capacity of that particular soil at that particular foundation level. Okay, that information also we need to design the bridges. Okay, and next one, what is a contour plan? I think you all know about the contourings, right? What do you mean contour? What contour plans will give? What contour plans will give? Contour diagrams ఏమి ఇస్తుందమ్మా, ఏమి ఇన్ఫర్మేషన్ ఇస్తుంది? Guys, you have to respond. If you are not responding, I won't continue the class. I'm telling you many times.
సార్ స్లోప్ గురించి చెప్తారు సార్.
స్లోప్ అంటే ఏం స్లోప్ చెప్తుంది?
సార్ వ్యాలీ కానీ హిల్స్ కానీ వాట్ ఫర్ రెడ్యూస్ లెవెల్ గురించి చెప్తారు సార్.
It will give levels. Okay, ups and downs. Understand? So contour plans will give the ups and downs of the bed of the river. Okay, on both sides, on upstream side and downstream side. Okay, U/S ante din upstream antaru, D/S ante din downstream antaru. Okay, if you see any bridge or any dam, okay, the other part of the dam will call downstream. If the river is flowing like this, okay, this is called upstream and the other side is called downstream. Understand? So this contour plan will use the levels of this particular stream. Okay, so what is the levels? I mean our levels, ups and downs, enta levels unnai anedi manaku telustundi. Ground position I can tell you as. Okay, so that is the meaning of contour plans. That information also we need, okay, in terms of designing the bridges. And the last one, soil profile. Soil profile near to the site. Okay, understand? So near to the site ante, so e sides lo gaani till around, okay, oka 200 to 300 meters width varaku, what is the type of the soil, what is the soil profile? Okay, so in the vicinity of, you know, bridge site, and record of various tests conducted at the site. So ఈ సాయిల్ టెస్టింగ్స్ కూడా చేసి ఉండాలి మనం. ఓకే, ఈ సాయిల్ యొక్క ఇన్ఫర్మేషన్, ఈ సాయిల్ యొక్క ప్రొఫైల్ అండ్ ఈ సాయిల్స్ యొక్క ఆల్ వేరియస్ టెస్ట్ రిజల్ట్స్. ఓకే, సాయిల్ యొక్క టెస్ట్ రిజల్ట్స్ అంటే యూజువల్లీ వీ కండక్ట్ ఆల్ టైప్ ఆఫ్ సాయిల్ టెస్ట్ కదా. అటర్బర్గ్ లిమిట్స్ టెస్ట్ చేస్తాం. వాట్ ఈస్ లిక్విడ్ లిమిట్, ప్లాస్టిక్ లిమిట్, ఓకే, shrinkage limit and all, and what is the bearing capacity of that soil, what is the unconfined and compression strength of soil, everything. So that all information you have to get before you start the designing of the bridge. Okay, that gives the soil profile, okay, which is near to the bridge site. Understand? So this is what about data required for in terms of nature of stream. Okay, chond enta data kavalo, we can't expect that just like that we are going to design the bridges. No, we need lot of data to design the bridge. Okay, so this is the third major head, which is nothing but data required for the nature of the stream. Okay, and the fourth one. So let's see the fourth one. Superstructure data. Superstructure data. What do you mean superstructure data? What we need under superstructure data? First one, what is the proposed clear roadway, okay, over the bridge meda, what is the proposed clear roadway? Okay, why? Because let's see, so this is the existing road, okay, and this is also an existing road. Okay, so there is a water stream which is flowing like this. Okay, you want to construct a bridge, right? So you are going to construct a bridge on this. So what is the existing proposed road for this bridge, or what is the existing proposed bridge width అనేది చూడాలి. Okay, sometimes what happens, usually this road width is like this, but the proposed bridge may be like this with more in width అన్నమాట. Okay, more width కూడా bridge propose చేస్తారు. Why? Because in future if you want to extend the road, again no need to construct any new bridge. So in that way, the roadway width, I mean based on the roadway width, based on the future proposed roadway widths, the bridge is going to be decided. Okay, so this is the clear roadway of the bridge. What is the proposing, or what they are proposing, the clear roadway of the bridge. Okay, so that also very, very important. Okay, and the next one, proposed width of footpaths. What is the proposed width of footpath? Because for every bridge there will be a footpath, isn't it? So what is the proposed width of footpath, and what is the proposed width of cycle tracks? Because don't expect that bridges will be only for vehicles. Okay, sometimes there will be a footpath, there will be cycle tracks, there will be a pedestrian walks. Okay, many things will be included in the bridges itself. Okay, and what is the central wedge, all this. Okay, so this also we have to know in terms of superstructure data, right? So what is the width of footpath? So whether I want to provide footpath only on one way, or I have to provide a footpath on the two ways, okay, that I have to decide. Understand? Next one, third one, what is the proposed formation level of road? What is the proposed formation level of road over the bridge? Over the bridge at the center. At the center. So every bridge will have the formation level. Okay. Why? Because see, so this is the top view, right? So let me draw the same bridge in terms of elevation. Okay. So basically your road will start from here. Okay. So definitely if you want to construct any bridges, usually bridges will have some particular elevated height. So your bridge, ఇది bridge అనుకోండి. Okay, so obviously you should have like this, and then you should have a in this way. Okay, so the road levels, sometimes it will be in this way. Lekapothe, you know, sometimes the road levels will be with the same height, with the same road level lone untai. Okay, so let us talk about this is the flyover. If it is not a flyover, if it's just a bridge which is constructed over a river, so the road level and the bridge level will be in the same elevated height. Okay, so these are the flyovers and these are the bridges which are constructed over a rivers. Okay, road levels ive untai. Understand? So here, if you want to measure what is the bridge height, what is the formation level of the road at the center of the bridge annaru ankondi, this height I need. Okay, so this is the height of the bridge. Always you have to measure the height of the bridge at the center of the bridge. Antegani ikkada measure cheyakodu. Okay, always we have to measure at the center height of the bridge, which gives the formation level of the road over the bridge at the center, right? And the next one, which is important, what is the gradient? What is the gradient of the bridge? And next one, what is the camber for the bridge? Okay, and what is the sight distance for the bridge? ఇవన్నీ మీకు ట్రాన్స్పోర్టేషన్ లో చదివే ఉంటారు మీరు, isn't it? Yes or no? Okay, what do you mean camber? What do you mean sight distance? What do you mean stopping sight distance? What is the super elevation? What is the gradient? Right? This is all information you have to know in designing the bridges. Okay, so for getting the data from the superstructure data, right guys? And the next one, which is the last one in terms of superstructure data, the proposed bridge can be designed to pass what is the maximum floods taking place at the bridges, and what is the ordinary floods. Okay, and what is the dry season, and what is the monsoon season. Okay, that all information I have to know in terms of passing. Okay, dips to pass excess discharge in high floods. Sometimes, few bridges they will construct, okay, even to allow water over the bridge in a high flood levels. Okosari HFL cross a goda, water will flow. Okay, and even at the times also your bridge should be in a position to allow water from upstream to downstream. Okay, so that information also we have to get in terms of superstructure data. Okay, that means your bridge should be in a position to transfer even water from upstream to downstream at a very high flood levels. Okay, that we call as an unexpected floods and matter. Okay, so that is what about superstructure data which we required, guys. Okay, and next one is foundation data. Foundation data. Okay, let me take the attendance first. I think we have only 6 minutes time. Let me take attendance, then I will continue the class. Okay. So class strength is 35. Yes. Yes. Okay, guys. Yeah, I took attendance and the class strength is 35. Okay, I will post it. Okay, so let me continue the class. Okay, so foundation data, right? What things comes under the foundation data? In data column foundation data lo related to first one. What is the type of foundation? Okay, what type of foundation is suitable for that particular location? Okay, type of foundation and whether it is an open foundation, and next one whether it can be a well foundation, and whether it can be an RCC pile foundation. Okay, these are the different types of foundations which we have. Okay, this also you have to make sure before designing the bridges. Clear? Open foundation, well foundation, RCC pile foundation. Okay, and the next one, seventh one, which is data for existing structure. Data for existing structure. What do you mean that? So because if you are proposing the new bridge, so definitely you have to collect information of the old bridge which was already existed on that particular stream. Okay, so that information also you have to collect. A.M.I.E information adi, what is the position of existing bridge, or nothing but index plan under. Okay, our old bridge yokka drawings, old bridge yokka index plan drawings, everything we need to design the new bridge. And next one, what is the details of the existing bridge? Old existing bridge yokka details kavali. What type of details amma? Size, span, type of bridge, okay, depth of foundation, okay, and height of bridge. Okay, so what is sectional area of high flood level under the bridges? So this information you should know from the old bridge to design the new bridges. Okay, position, details like what is the size of the bridge, what is the span of the bridge, what is the type of bridge, what type of foundation they have used for that old bridge, what is the height of the bridge, what is the sectional area of the bridge, okay, in terms of what is the high flood level, everything. Because if you know this data, you to design the new bridges, okay, your work nature will be very easy. Okay, So in that way, that information is also very, very important. And the last one is miscellaneous data. Okay, miscellaneous data. What do you mean miscellaneous data, ma? Can anyone? What type of data can be considered as a miscellaneous data? Okay, there are many things. Okay, miscellaneous data. What is the name of the nearest inhabited locality? Okay, inhabited locality యొక్క names ఏమన్నా కావాలా? Okay, and the next one, what are the facilities available? Because the site engineers or the labor, everything, they want to stay nearby the bridges only. So what are the facilities available? Like, you know, availability of drinking water, availability for the accommodations, availability of the materials. These are all data you have to collect before designing the new bridges. And what is the nearest railway station? Okay, is there any nearest railway station is there or not? Okay, that also you have to choose. Okay, and what is the nearest means of transport for materials? Materials transportation ke availability emanna unnaya? Okay, materials transportation. Okay, like this, availability of power, electrical power availability unda leda? Okay, and next, availability of like stones or quarries. Okay, availability of material like cement, steel, okay, timber, all this. Okay, and the next one, availability of, preparation of drawings, plans. Okay, so what is the details of the subsurface investigations? Okay, understand? So like this, these are all miscellaneous data also you require to design the bridges, guys. Okay, so this is what about the essential design data for bridges. Clear? So this is what about this, and in the next class we are going to discuss very important topic, which is economic span of the bridge. How to calculate the economic span of the bridge. In the previous class, in the bridge terminology, I have told you what is clear span, what is effective span, and what is economical span. What do you mean economical span, Amma? The cost of superstructure is equal to cost of substructure. That span is going to known as economical span. Okay, so that what we are going to discuss